We're going to take a look at using a network analyzer to display the characteristics of filters, some filters and some different circuits. What we have here is an 8407 Hewlett-Packard network analyzer. It was manufactured in the late 60s, and it has to be teamed up with either an 8601 or there's another specific sweeper that it needs to work with, because the 8407 requires an RF input that's 100 meg above the signal, the frequency you're putting out. So it takes you can't just use any generator, because the generator has to put out a signal that's at the frequency desired plus one at the frequency desired plus 100 megahertz. So let's take a look and see how we use it. Basically, it has a reference input and it has a test input, and it's going to compare the two of those and display them on the screen. So let's take and do a little quick calibration. The output out of the sweeper comes up and runs into a power divider. This is a homemade one, and I don't have the specific cables that it calls out for. It came with a precision power divider and dual insulated BNC cables that were matched very well to each other. That allowed it to make dB measurements down to around a 5/100ths of a dB to a 1/10 of a dB very easily. It has a setting over here on the front panel. We have a horizontal gain setting here of 10, 5, 1 or quarter dB per division on the screen. So at a quarter dB per division, it makes it relatively easy to see changes of 5/100ths of a dB or so. The 8601 can put out CW, symmetrical sweep, and we'll use symmetrical sweep to look at a bandpass filter a little later on. Video sweep, which in video sweep it's going to sweep from the bottom of this range up to whatever you have set in to the dial here. So for a typical low pass filter, we might set this up to 50 megahertz, and now I'll sweep between 1 meg and 50 megahertz from left to right on the screen. The other setting we have is full. When we go to full, depending on the range, your frequency range you have it set to, it'll either go from 0.1 to 11 megahertz, or it'll go from 1 to 110 megahertz. So let's go ahead and start initially with doing a little calibration check and setting up the 8407. Okay, to start with, we have the input to it run through the power splitter, so we have both the reference channel and the test channel have the same amplitude or fairly close, and we're going to set it up so that right in the middle of the screen is 0 dB. So we'll be able to read plus 40 dB and minus 40 dB from that point. So we're setting 10 dB per division, so we'll set it to 5 dB per division. You notice we went down off of the screen. So what we need to do is change our settings a little bit to where we stay more in the middle of the screen, and we can do that by adjusting the dB switches. The object is to have no shift. See, we're getting closer. We only shift 1.5, a little over 1.5 divisions when we go down to the quarter dB position. So I have an amplitude vernier here I can adjust. I just hit right at the bottom of its range, so I'm going to take out some more with the 1 dB position, and there it stays put, switching between ranges. Now if I were to go to a full sweep, we start to see a little bit of the imbalance in the cables and the rest of the system, but not a whole lot. We're just off maybe a 1/10 of a dB right here. So we're all set. Now the next thing we need, now we have, this is going to be our 0 dB settings. We have on a dial showing -20 and -3. We'll set that to where it shows 0 dB. And now we're ready to measure something. First, let's just throw in a step attenuator, and we'll take a look at that. Okay, I have a step attenuator in the circuit, so let's throw in 10 dB of attenuation. It went down 1 division. That's what we'd expect. If we come back to the 2.5 dB per division setting, it should drop down 4 divisions. And it does. So I could go 10, 20, 30, 40 dB. I can go 10 through 40 dB and I get 10 dB as shift for each 10 dB on the screen. Let's hook up an actual filter to it and see how that looks. I've connected the output low pass filter on a version 3 linear amplifier board. So between the coils here and the capacitors, that makes up our filter, and this is the output and an input here. So what we'll do is take a look at that on the screen and see how that looks. Here we're running a full sweep from 1 megahertz on this side to 110 megahertz on this side. So actually 111. So let's take a look at it a little closer to where we can get a little more detail. We'll switch from full sweep on the generator to video sweep, and now we're sweeping between 1 megahertz and 50 megahertz. So basically we have 5 megahertz per division here. We can look here, here's 5, 10, 15. So we start rolling off right a little over 15 megahertz. And down here, this is about 40 megahertz down, 40 dB down. Let's take a look at the insertion loss right here. We can do that easily by just changing the dB scale. Now that's 2.5 dB per division. That's 1 dB per division. And if you notice, we started right here. So this is 1 dB down, right around 14 megahertz where we want to start rolling off. We're about 1 dB down. So that's about right. That's not bad at all. So we had about a 1 dB insertion loss. If we go back to 10 dB per division, we can see we've got about 40 down here. We can look at this in a little more detail by changing putting 10 dB of gain in. We don't read perfect up here because I'm getting a little compression on the amplifier there. But what we can see is I've got about 10, 20, 30, 40 dB plus a little, then it comes back up to about 40 dB for the low pass filter. Let's look for that in a little more detail. I'm going to take it back down and we'll see if we can measure our insertion loss a little more accurately. We'll set down the gain. I'm at 1/4 dB per division now. I can come over here and add gain to get it back up on the screen. And I bring it back down to the center if I can. Which I can't get it right back down to the center. But basically, what we have here is -1 dB right at that point right there. And we have, remember these are 1/4 dB per division, 1/4 dB, 1/2 dB, about 0.75 dB of ripple on the filter. Let's take a look at a WA2 EBY amplifier low pass filter board. This has got a 160 through 10 meter low pass filters built into it. There's about five different, 1, 2, 3, 4, 5, 6 band positions. Each one of these is a low-pass filter and selected by the switch. So let's hook that up and see what that looks like. First, we hook our input and output cables together and set the screen up for 0 dB reference. We're getting a little roll off here. It's down maybe 2/10 of a dB at 110 at 50 meg. If we go full with this, I'm running some RG 174 jumper cables, and you can start to see the effect just moving the cables around. I've got longer cables than I should have to do an accurate measurement. This is about 100 meg, so we're not going to worry a whole lot about that. This is down a little over 1/4 dB, so I'm getting some roll off through those particular cables themselves. But that won't bother us for looking at the filter. We have our input and output connected here across the back of the switch, and let's take a look and see what it looks like on the network analyzer. Okay, here's our low pass filter. This is about 95 meg or so, so that's out quite a ways, so we won't worry about that. Let's turn the switch. You can see the bandwidth getting wider on the filter. This would be the 10 meter position. So let's take a little closer look. Okay, we've got our 160 meter filter in. We're sweeping here between 100 kilohertz and 11 megahertz. So we have roughly 1 megahertz per division. So we start rolling off at this point here. Let's look at the insertion loss first. We'll just go down to 1/4 dB per division, and boy, this doesn't have much loss. From here to here is 1/4 of a dB, so it's less than 1/2 a dB, or it's less than 5/100ths of a dB loss, insertion loss to the filter. Let's take and measure the frequency here where it starts rolling off, and filters are spec'd in bandwidth to the 3 dB position, so I've got a 2.5 dB per division, so I'll just roll it off 2.5 dB and we'll measure the frequency. So I'll just take it down towards down there. The way I do that is I just take the sweep generator and put it in manual mode, and now I can adjust the dot anywhere I want. I'll adjust it to right there. That's about 2.5 dB down. See, on the 8601 we're running full sweep. We have an auxiliary output port on the 8601. We just run that over to our frequency counter, and our frequency counter says it's 2.69 megahertz to where the 3 dB point is. Let's roll it down to the 40 dB. I'll roll it with it on the camera first. It's 40 dB down at that position, and 6.196 megahertz, it's 40 dB down. Okay, we're back. Let's change band positions. Remember, we got about 1 megahertz per division on this setting. So 1, 2, 3, 4 megahertz. So this is going to be our 80 meter filter. Let's change sweep ranges. We'll go to video, and we'll go to 50 meg. So right now each division here is about 5 megahertz. So that's going to be our 40 meter. That should be our 20 meter. 15, and 10. We can measure the insertion loss on any one of these along the way. We're 1/4 dB per division, so we have less than a 1/4 dB insertion loss on the filter. So just moving the board, you can see, moves the cables. So further up in frequency, up around 80-100 meg, it makes a difference. We take and increase the gain here. We come back out of the grass down in the bottom a little bit, and we can see that we do indeed have pretty much 40 dB of attenuation on just about any setting. Okay, I've hooked up a Kits and Parts bandpass filter. This one has a problem with it because it's got a high insertion loss. I haven't fixed it yet, so it has higher than any I've seen. So I'm not sure whether the filter's is filter design or what. So I won't say on that. I may have a defective construction here also. This is a 20-meter filter, so we have to set up a little bit different for a bandpass filter. Now I'm set up for a symmetrical sweep. I'm about 14.5 megahertz centered. We'll measure that in a little bit. And I'm set to where I'm running 3 megahertz sweep width. So with 10 divisions of display on the screen, each division will be equal to about 300 kilohertz. Okay, here's our filter shape, and remember, each division is worth about 300 kilohertz, so we got a little less than 300 kilohertz there. And we can measure the loss of the filter by bringing it back up to where it should be, and I have about minus 11 dB. Now we can adjust this, and it makes this real easy to do because you can see exactly what's happening. So I can flatten that out there. We've got 3 tuning capacitors on here. I'm thinking I've got a bad component in here because it doesn't really tune the way it should, and it's got too much loss. But as you can see that section's probably okay because I can tune all the way through both sides. This section, I hit the end of the capacitor, so I may have a problem in this section. That way I can tune it out. This one I'm right in at the limits too. So I'll make it flat. Let's measure the frequency on the filter. Let's change this sweep symmetry. So instead of going 3 megahertz wide, I'll go 1 megahertz wide. What that does is make each division here now worth 100 kilohertz. So we can see we've got somewhere around 1, 2, about 3, not quite 3, maybe 250 kilohertz worth of band spread. We'll set it so it's easier to measure the 3 dB. To do that, we actually want to be down 2.5 dB per division point. We can bring it back to the center of the screen by adjusting things. So between this point and this point is going to be 2.5 dB down on each side. So we'll go to manual sweep, and I can run it back and forth. We'll come up to where we're 1 division down, which is 2.5 dB. That's measuring 13.997. And we'll run to the other side. and that's 14,291. So what we're just a little bit set a little bit low with our adjustments. We'd need to adjust that up. So you can see what a neat tool the network analyzer is. You'd say, boy, if I only had the money to buy something like this. Well, that's true back in the 60s when they were the best thing out there. But I recently saw a complete system on eBay that had the 8601, they had the 8412 phase and magnitude display, and the 8407 network analyzer that was supposed to all be working. The whole system was about $400. So, and it had a right of return. So if you keep an eye out, you may be able to come across something that's fairly reasonable in price. Mine, I have they make two other displays. They make an 8413 meter display, an 8414, which is a Smith chart plot display. I've never used those yet, so I haven't got to where I can I've never had them turned on yet. So anyway, for HF work, the 110 megahertz limit isn't any problem at all. So till the next time, happy tweaking. The more equipment you have, the more fun it is. 73s.
I left my old home to ramble this country. My mother and dad said, son, don't go.